Hey guys, let's do a problem example that is a little bit challenging, but nothing too terrible. So I made this problem up. I don't know if it's real or not, but a 12-inch diameter valve wheel turns an axle of a submarine door. If the mechanical advantage is 24-1, what is the radius of the axle? So what do you have? So you can label. It's always good to draw your system. So you have your wheel, you have your axle. So the wheel diameter, right, is 12-inch diameter, right? So that's the diameter of the wheel. And that happens to be my distance of the effort, right? So let's call it DE, distance of the effort. The distance of resistance, the axle diameter, is unknown. And then of course, we know that the mechanical advantage is, right, 24, or 24-1, same thing. So, you have this. So in this case, the only formula you can use is the one for ideal mechanical advantage, because you're not given any forces. So you just have to assume that the wheel and axle system there is ideal, which it's not, but you know, for the purpose of this, that's what you gotta do. So, looking at the formula for ideal mechanical advantage, right? You take the diameter of the effort and divide by diameter of the resistance. So in this case, right, effort, again, it's good to note, that's my axle. That, whoops, see, almost made that mistake. My wheel is driving and the axle's over here. So it's always good to kind of keep that in mind. So that's why I put it there. And what's happening is you are given the mechanical advantage, but you don't have the diameter of resistance, right? So diameter of the axle. So you can solve for it because of course you have the effort, which is 12, that's the diameter, divided by, and now you have to be careful. dr is the diameter, whereas for the axle, so the diameter here, right, dr, right, when you do all that fancy math, 24 dr, so you're gonna get, after you calculate it, you're gonna get dr equals 0.5, right, inches, but you have to realize that this is the actual diameter, and the question asks for the radius, so of course, the radius of the axle, right, is 0.5 inches divided by 2, which is a 1/4 inch or 0.25 inches, okay? So that's how you work those out. If you don't know what I did here, quickly, I multiplied both sides by dr, so I got 24 dr equals 12, and then I divided both sides by 24, which of course this canceled out, and that gave me the 0.5 here. So that's an example problem that you will be expected to solve.